All right, everybody, this is it. Algebra 2, Schlansky's Guide to 65. Let's go. First things first, strategies. If you see variables in the problem and you see variables in the answers, use your multiple choice strategy. I'm going to store 10 for X. I'm going to store 15 for Y. If you have a favorite number that you want to use, fine. Nothing negative, no zeros, no ones. Don't love 2 either. So I'm going to go to my calculator. I'm going to do my 10 store as X. I'm going to do my 15 store as Y. Alpha 1 for the Y. I'm going to type in the original problem. Alpha X for the fraction. That's 6X to the third plus 17X squared plus 10X plus 2 over 2X plus 3. I get something. In this case, 7802 over 23. All right, don't be freaked out by a fraction or a decimal. And now I'm going to go through each of the choices, and I'm going to see which one matches up. 3x squared plus 4x minus 1 plus alpha x 5 over 2x plus 3. I get 7802 over 23. Is that the same value? Yes, that's my answer. Be careful. You may want to type in all 4 choices. If it's a situation where it says factor to completely or something to that effect, more than one answer may be equivalent. But in this case, there's only one possible answer that will work. Same thing for i's, same thing for radicals. Just make sure you know how to type everything in. To access a radical, basically alpha window has everything that you need. So your radicals are here, your log bases are here, your absolute values are here. Anything that you need generally is an alpha window. And then I is second decimal point if you need to type the I in for whatever reason. Next strategy, equations. If it's a multiple choice equation, do not do the algebra because I can't tell you how many students are going to do all the algebra. Everything's going to be perfect. They're not going to check. They're going to get the answer wrong. All you have to do is just check each answer. So I'm going to start with choice 1, 1. You don't have to store, but I'm going to store 1 is X instead of all the parentheses and whatnot. I'm going to type in the left-hand side, radical x plus 3. I'm going to type in the right-hand side, 3 minus x. Do they match? Yes. I got 2 equals 2, so that means that 1 is the solution. Well, choice 3 is saying that 1 and 6 are solutions. So to make this a little bit bigger. So now let's try 6. So I'm going to do 6 store as x. I can just copy and paste what I already typed in. Radical x plus 3, 3 minus x. For 6, I get 3 equals negative 3. That's not correct, so 6 is not correct. So the answer is choice 1. Just take each answer, check it. You can do it with storing, without storing. If you get an error, it doesn't work. And don't be freaked out for something like number 6. We just type that whole thing in and we do store as x. It'll make it into a decimal, no big deal. And now I've got something that hopefully, if this is Guide to 65, you probably will want to use. If you don't have strong algebra skills to solve any equation, we're going to use y1, y2 intersect. Yes, it would be ideal to be able to do all the algebra, but think of this as a backup if you can't. So the work you have to show, y1 equals the left-hand side, y2 equals the right-hand side, intersect. X, 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 solo X, X only the X value when you're doing Y1, Y2 intersect. So I'm going to get my calculator up. I'm going to go to Y equals. I'm going to type the left-hand side into Y1. That's radical 56 minus X. X on the right-hand side. I always start with zoom 6 because I'm often manipulating my window. Second, trace, which is next to the graph button, option 5, intersects. I'm going to move my cursor using the right and left arrows as close to that point as possible. But if there's only one intersection, it'll find it as long as it's in the window. Enter, enter, enter. If there are multiple answers, you will need to do each one individually. X equals 7. If it says to solve it algebraically, you will get half of the points of the question. If it doesn't say to solve algebraically, you get full credit, but this is the work you need to show for it. All right, we're done with strategies. Now we do some actual math. Is x minus 6 a factor? To determine if something's a factor, I need to find the remainder using remainder theorem. So I'm going to substitute the opposite of what I'm dividing by in for x. The opposite of x minus 6 is positive 6. I'm going to substitute 6 in for all the x's. When you type this in, we can do it with storing or without. I like storing, which many of you know. But you can type it in exactly as you see it. Either way will be fine. For the multiple choice, which we're going to see next, you're going to see why the storing is definitely better. So I've got 6 store as x. I'm going to type in x to the third minus 6x squared plus 4x minus 1. So what I just did is found the remainder. The remainder is 23. If the remainder is 0, then yes, it's a factor because it goes in evenly. If it's anything else, then it's not. Since that is not 0, the answer is no, because stay away from it in your explanations, because the remainder is 23. If you got 0, then it'll be yes, because the remainder is 0. That brings us to the multiple choice version of this. We're just going to go through each choice. Which binomial is a factor? Well, I'm going to start by seeing if x minus 2 is a factor by substituting 2 in. I don't have to show the work on paper since it's multiple choice. So I'm going to do 2 store as x. I'm going to type in x to the fourth minus 4x squared minus 4x plus 8. I got 0. Is that a factor? Yes, that's my answer. But just to show you, if I want to check choice 2 now, I can just store -2 and then copy and paste since I already typed it in. That's another benefit of storing, is you can save yourself some time by doing that. I'm not going to go through all the choices right now, so I'm trying to get this thing finished and go home. Well, I'm not home, but not here. But choice 1 would be the answer. Which graph has imaginary roots? Real zeros hit the x-axis. Imaginary zeros don't. Imaginary zeros or roots or solutions don't hit the x-axis. Which choice does not hit the x-axis? Well, this one. It doesn't hit the x-axis. That's it. If they give you an equation, type it into y equals and look at it. I would include that picture if it is open response, but real zeros hit the x-axis, imaginary zeros don't. Writing a polynomial equation, I need the factors. Before I can get the factors, I need the zeros. So my zeros, it hits the x-axis at -2 and at +3. So if -2 is a 0, then x plus 2 is a factor. If +3 is a 0, then x minus 3 is a factor. 3 things to be careful of. 1, don't forget your y equals. 2, check for double roots. Are there any double roots? Does it bounce off the x-axis? Yes, it bounces off the x-axis. So that factor gets a squared. And finally, check to see if it's positive or negative. If it opens up to the right, it's positive. If it opens down to the right, then it's negative. In this case, it's positive. Look at your answers carefully. X minus 2 is not correct. The x plus 2 should be squared. X minus 3, that's it. I think these are easier when they're multiple choice. I think when they're open response, it's hard to remember exactly where everything goes, but that's why the multiple choice is on the guide to 65. End behavior. As x approaches -infinity, that means as I look to the left. As x approaches positive infinity, that means as I look to the right. F of x is up and down. Positive infinity is up, and again, negative infinity is down. Now for choices 1 and 3, we did talk about U-shaped, chair-shaped, positive, negative, but if you don't know any of that, you can just go to your calculator and type in. So for choice 3, -x to the third plus 2x minus 6, zoom 6, looks something like that. And for choice 1, I can go back to y equals, and I've got x to the 4th plus 2x squared plus 1, zoom 6, looks something like that. So now I look at the choices. I want, as I go to the left, for it to go up. That's good. That's not. That's not. That's good. As I go to the right, it should point down. That's not pointing down. That is pointing down. That's my answer. Just make sure you understand your end behavior. As long as you understand your end behavior, it's a pretty simple topic. I know it looks confusing, but I think for the most part, students understand this. So if you don't understand this, hopefully this helped. And if not, then ask me for more help. Next type of question. Whenever you see two things equal to each other, basically an equation with some weird stuff and talking about rounding, or if you see f of x equals g of x or p of x equals q of x, that is your y1, y2 intersect. I know we did it as a strategy before. This is not a strategy. This is the way you have to do the question. So I'm going to get my calculator back up. I'm going to go to y equals. I'm going to type the left-hand side into y1 exactly as I see it. So I'm going to go alpha window 1 for the absolute value bars, x squared minus 9 minus 3 outside the bars. Y2 is my right-hand side, alpha window 5 for log base. Again, alpha window has pretty much everything you need in this course. Zoom 6, so I see the intersections, yes. Let's blow this up, and I don't think I need to show the other screen at this point. So to find the intersection, second trace, intersect. There's two of them. I'm going to do one at a time. I like to always go left to right. Enter, enter, enter. X, 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 solo X. 2.29 is one answer. I don't have to show the work I showed before because it is multiple choice. And I got another one. So let's go second trace again. Option 5 again. Use the left and right cursors to go to the other intersection point. Enter, enter, enter. 3.63. I look at my choices. I've got my answer. You may need to adjust your window. For this particular question, you did not. And if you want to adjust your window, if you go to window, if I want to see more of the left, that's my x min. Right is my x max. Bottom is my y min. 10 is my y max. Let's keep on rolling. We've got graphs, specifically polynomial graphs. To graph anything, just type it into y equals. If it's giving you a domain, that means that I'm only graphing it from -1 to 4. So those are the x values that I'm going to copy down, and no arrows. If there is no domain, then I will put arrows, and I'm just going to plot what fits. The graphs from -10 to 10, so I'm only going to plot the points from -10 to 10. So I'm going to go back to my y equals. I've got, I'm going to clear that out. I've got x to the 3rd minus 6x squared plus 9x plus 6. I'm going to go zoom 6. Well, I don't have to go zoom 6, but that's what it looks like. I'm going to go to my table. I'm going to copy down my values from -1 to 4. -10, 6, 10. 8. And then I've got 6, 10. I plot those points. So I've got -1, -10. I've got 0, 6. I've got 1, 10. I've got 2, 8. I've got 3, 6. I've got 4, 10. I can look at the graph again if I want to see what it looks like by hitting graph. Again, because it gave me a domain, no arrows. and I'm going to draw a curve connecting. It shouldn't go past those points, and that is my graph. Again, for number 29, because there is no domain, I would have to put arrows. That brings the inverse. Inverse switch x and y, switch x and y. To find inverse and understand the symbol for inverse, you may see f inverse of x. That is the symbol for inverse. I switch x and y. So instead of y equals, I write x equals. Instead of x, I write y. Now I solve for y. Divide by 4. You may see it as x minus 5 over 4, or you may have to draw your heart, break it apart. In this case, that's what I have to do since I don't see that previous answer there. And that's my answer. Another option is to use a strategy that I taught you. So let's do that now. We're going to start by typing this into y1. So I'm going to go to my calculator. I'm going to type in y equals 4x plus 5. I'm going to go to my table. I'm going to write down 3 nice points. Let's go -2, -3, -1, 1, 0, 5. So that was -2, -3. -1, 1, 0, 5. And since inverse means switch x and y, I'm going to switch x and y. So I have -3, -2, 1, -1, 5, 0. My answer must have this table. So now I'm going to go to my calculator, and I'm going to go to y equals, and I'm going to type in the 4 choices. I can't type choice 1 in. That's not the answer. There's no x equals. So it'd have to be y equals. So I'm just not going to put that in for this particular problem. So y2, I'll put choice 2, which is 1/4 x minus 5/4. Choice 3 is y equals 4x minus 5. And then 1/4x plus 5. I go to my table, and I am looking for what I circled, -3, -2. So -3, -2 is red. 1, -1 is red and black, but red works for both. 5, 0 is red. Red is y2. y2 is this one right here. So the algebra can get nasty, which is why I like the strategy. If it's open response, the strategy is not going to help you. You're going to have to do this. But honestly, I would like you to be able to do it both ways because both ways aren't very difficult. That being said, algebraically can get difficult depending on the problem, where the strategy is not. Even symmetric to a y-axis, odd symmetric to the origin. Even is symmetric to the y-axis, odd is symmetric to the origin, meaning if I turn it upside down, I see the same thing. So I'm going to go to choice, I'm going to go to 34, I'm going to type in -x to the 4th plus 4. -x to the 4th plus 4. I'm going to do zoom 6. Is that symmetric to the y-axis? Yes. So if it's open response, I'm going to give a sketch. And I'm going to say even because it's symmetric to the y-axis. Just to quickly transition to this here, just so you can kind of see a bunch of examples. Number 1 is even because, again, it's symmetric to the y-axis. 2 is odd because it's symmetric to the origin. I could turn it upside down and see the same thing. Or if you pick a point and you count to the origin, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, it lands on itself. That's odd, symmetric to the origin. And in number 3, it's not symmetric to the y-axis. It's not symmetric to the origin. It's neither. Okay, that's what it would look like. You can take a look at 4, 5, and 6. Odd is symmetric to the origin. 5 is neither. And 6 is even because it's symmetric to the y-axis. All right, what's next? I am not even making a dent looking at this progress bar on the side. You need to know your up, down, left, right rules. So, should I write them out? I guess I should write them out. If I am adding to the whole thing, that's up. If I am subtracting from the whole thing, that's down. If I am adding to just the x, it's always the opposite direction I would think. For x, that's left. And if I'm subtracting from just the x, then it's right. So this minus 4 is just where the x is, so that's right 4. And the plus 2 is to the whole thing, so that's up 2. It's just knowing these rules, so make sure you know these rules. Average rate of y2 minus y1 over x2 minus x1. Whenever they ask you for average rate of change, that's your formula. I always want to see a table. It says between 1 and 5, so those are my x values. They have to tell you your x values. If they give you a graph, then you pull the values from the graph. If they give you an equation, then type it into y equals and go to your table. 1 is 112, 5 is 48. So y2 minus y1, I do bottom minus top. 48 minus 112, x2 minus x1, bottom minus top. Now that I have it, 48 minus 112, I let the calculator do the work for me. 5 minus 1, negative 16. Just be careful if you're subtracting a negative, I would just write minus negative. So just be careful with the negatives, but other than that, it's pretty straightforward. The context sentences are not on the guide to 65, but you may be asked that on average from 1 to 5 seconds, the height of the ball decreased by 16 feet per second would be the context sentence. Radicals are fractional exponents, and it's always the power over the root. So the x to the 3 over 4 times x to the, if there is no root written, let's make it a little bit bigger, then the root is 2. So that's 5 over 2. And then clean it up. I'm multiplying. When I multiply, I add my exponents. So basically, I'm doing 3/4 plus 5/2. And I don't trust anybody's ability to do anything you learned in middle school. I won't name that specific middle school. And I get 13 over 4. So the answer is just x to the 13 over 4. You may have to multiply and divide. That's it. Radicals are fractional exponents, power over the root, and then multiplication. You're adding your exponents, division you're subtracting. All right, we've got graphing exponential and logarithmic functions. So for both exponential and logarithmic functions, there's an asymptote. The easiest way, again, this is a guide to 65. We're going to just graph it like we graphed the polynomial graph before. I'm going to go to y equals. I'm going to type in 2 to the power of x minus 3. I'm going to go to my table, and I'm going to see this negative 3, 3, 3, 3, 3, 3, 3. And before it gets there, I see the negative 2.99999. It's getting closer and closer to negative 3. It's never touching negative 3. Negative 3 is the asymptote. It's in the y column, so the asymptote is y equals negative 3. So at y equals negative 3, y equals is a horizontal line, I make an asymptote. Beyond that, I'm just going to plot points like I normally would. Nice points only. I do not like those points. I'm going to go 0, negative 2, 1, negative 1. I've got 2, 1, 3, 5. That's all it's going to fit. So that's all I'm going to plot. 0, negative 2, 1, negative 1, 2, 1, 3, 5. If you're not sure what it looks like, you can look at the graph. Make sure when you draw it, it gets closer and closer, but it does not touch the asymptote. It also shouldn't hook back up. That's your graph. I'm not super concerned about domain and range as far as it being commonly asked. I probably could have taken that off the guide to 65, but I'll talk about it. Domain for any exponential is always negative infinity to infinity because left to right there's graph. The range starts at -3, the asymptote value. It's not included, so it gets a parenthesis, comma, infinity. I'm not super concerned about domain and range. So if you understand everything else, but not domain and range, it should be fun. End behavior, as x approaches, let's do as x approaches positive infinity first. As x approaches positive infinity, that means as I go to the right, the graph is going up, positive infinity. As x approaches negative infinity to the left, it's pointing not up to positive infinity, not down to negative infinity, it's pointing at the asymptote. If it's pointing at the asymptote, I put the asymptote's value, which in this case is -3. Log graphs are very similar, but they're going to have a vertical asymptote instead. Also, the calculator is not good at graphing logs, so just understand that. You have to understand what it looks like. But I'm still going to start the same way. I'm going to go to y equals. I'm going to type in 4 for log base, alpha window 5, 1/2 x minus 3. Let me get back up there. I'm having some trouble here. Come on, get there. Come on, there we go. X minus 3 plus 1. I can hit graph. I've seen worse log graphs in the calculator before, but it's not generally good at that. So I'm going to go to my table either way, and you're going to see a bunch of errors. As far as the asymptote goes, it's the last error. So the last error is 3. It's in the x column, so the asymptote is x equals 3. So since it's x equals, it's a vertical line at 3. And that's my asymptote. I need some points to plot. I've got 4, 1. I've got 5, -3. I've got 7, -7. And that's it. And that's fine. Expect to get 3 or 4. 4, 1. 5, -3. 7, -7. If you're not seeing what it looks like, you can always go back and look at it. It's getting closer and closer to the asymptote without ever touching. Arrows on both ends of it, unless there's a domain or an interval. And that's your graph. Domain, well, the first x value is 3, but not including 3. So that's 3, comma, infinity, because it's pointing to the right. It's pointing both up and down, so the range is negative infinity to infinity. Again, I'm not super concerned with domain and range. It's not as commonly asked. End behavior, as x approaches positive 3, well, as I get close to positive 3, the graph is pointing up to positive infinity. As I go to the right, positive infinity, it's pointing down to negative infinity. Arrows point in two directions. So this arrow is pointing right, it's also pointing down. All right. Exponential regression equation. Easy, all in the calculator. Exponential regression equation, I'm going to go to Stat, Edit. To clear this stuff out, I'm going to go to L2 and hit Clear Enter. Clear Enter. I'm going to put my x's into L1, 2, 3, 4, 5, and my y's into L2. That's 101, that's 90, that's 79, that's 70, that's 62, that's 54. I'm going to go to Stat, Calc, and because it's asking for an exponential regression, I'm looking for exponential regression, which is expreg. You have to scroll down a little bit. So what's in this course is quadreg, xbreg and power reg. Because it wants exponential regression, I do xbreg. Everything should be set. X list should be L1, Y list should be L2. It tells me y equals a b to the power of x. So I'm going to write y equals a b to the power of x. I'm going to round to the nearest thousandth. So I'm going to write a equals, I don't think I'm going to have enough space there. I'm going to write a equals b equals. I've got 101.523. B is 0.883. So I have y equals, this is bothering me, 101.523.883 to the power of x. If it says to write an equation, you write an equation with two variables. This 29 does not exist yet. That's the end of the first question. Now it's giving me a value, 29 kPa. Well, kPa is y, so that's my y value. So I'm going to substitute 29 in for y. So I have 29 equals 101.523.883 to the power of x. To solve this, option 1, y1, y2 intersect. I'm going to do it for you quickly. I'm going to go to y equals, y1 is 29, y2 is 101.523.883 to the power of x. I know my y max has got to be more than 29, so I'm going to make my y max more than 29. I'm going to make it 50. I think I see my intersection, but I would rather see more of my right, which is my x max. I always at least double it. I see it, second trace, intersect, enter, 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 solo X. It wants it to the nearest hundredth, that's 10.07. The work I should show is the work I showed you before. I should write y1 equals 29, y2 equals 101.523.883 to the power of x, intersect. Now, ideally, you may or may not get full credit for that. Ideally, you know how to solve this algebraically using logs. So I'm going to do that now. So to solve it algebraically using logs, I'm going to isolate the base. So I'm going to divide by 101.523. Divide by 101.523. So we have 29 divided by 101.523 is 0.28 dot 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 equals 0.883 to the power of x. I do log both sides. The reason I do that is the x comes to the front. I divide both sides by log 0.883. I have x equals, I type that into the calculator. So I have alpha x log, I can do second answer or copy and paste it. Don't round until the very end, over log 0.883. And I get the same answer of 10.07. I would rather you do logs, but y1 intersect should do the trick. If it says algebraically, you would not get full credit for y1 and y2 intersect. But if it doesn't, which this one doesn't, then you're set. So I got some exponential regressions in there. We got a power regression. So a power regression is the same thing. I guess I'm going to do this question right now. I'm going to go to stat edit. I'm going to clear this stuff out. I'm going to do 10, 15, 20, 25, 30, 40. I'm going to do 12, 22, 39. Trying to make this interesting here. 58, 84, 150. Stat calc. Now, since it's asking for a power regression, I'm looking for power regression, which is, I don't see it, so I'm going to scroll. And there it is, option A. I hit enter. Everything is set. Enter, 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 enter. It says y equals a times x to the power of b. So it's a little bit different than the exponential formula. A x to the power of b. B and x switched. A equals b equals, it says hundredth. So 0.16, 1.83. Y equals 0.16, 1.8. Nope. X is x to the power of 1.83. That's my answer. I'm not going to do the follow-up questions right now. I'll talk about them quick. If it's giving you 55 miles per hour, that's x. You're going to substitute it in for x. And 100 feet is y. So you're going to substitute that in for y. And I would just use y1, y2 intersect for that. You could do reciprocal power, but I would just do y1, y2 intersect. Similarly, for the quadratic regression, any regression, I go stat edit, clear this stuff out. I probably should go to the other side. I'm gonna type in the data. So I've got 0, I've got 0.5, I've got 1, 1.5, 2, 2.5, I've got 0, I've got 78.1, 99.8, 84.4, 50.1, 15.6. Because it wants a quadratic regression, I'm going to do the same thing I did before. I'm going to go to stat, I'm going to go to calc. I'm looking for quadratic regression. Well, that's option 5, quad reg. Everything's good. It says the equation is y equals ax squared plus bx plus c. So I'm going to write y equals ax squared plus bx plus c. It says nearest 10th. I'm going to list a, b, and c. Negative 56.2, 139.3, C is 9.4. So I have y equals negative 56.2 x squared plus 139.3x plus 9.4. Just like the last question, I'm not going to go through the follow-up questions in detail, but it's giving you 1.75 hours. That's x, so you sub it in for x. And it's giving you 30, in a separate question, it's giving you 35 milligrams per liter. That's y, so you sub it in for y, and you do y1, y2 intersect. Recursive a1 equals an equals an minus 1. On my enhanced reference sheet, I wrote out my formulas and songs, including recursive, which is right there. You write that. From there, it's a pretty easy question to get correct. A1 is 18. And then you're telling me what you're doing to the previous term. And if you can't tell, you can subtract, divide, divide. So I'm going to subtract 9 and 18, 4.5 and 9. The second minus the first, not the first minus the second. So I'm going to do 9 minus 18, 4.5 minus 9. Do they subtract to the same thing? No. So I'm going to divide. 9 divided by 18, 4.5 divided by 9. Do they divide to the same thing? Yes. That means that I'm multiplying by 0.5 or 1/2. Which of the choice has that? That is choice number 1. It's got to be recursive, so it has to have the an minus 1. Choice 2 and 4 are not recursive, and 90% of the time in this course, for sequences, it's recursive. I'm guessing I have an open response coming up now. I do. Again, recursive a1 equals an equals an minus 1. Tell me what a1 is. a1 is 6. Tell me what you're doing to the previous term. If you don't know, subtract, subtract. 9 minus 6, 13.5 minus 9. Do not subtract, subtract to the same thing. 9 divided by 6, 13.5 divided by 9. Both divide to 1.5. So I'm multiplying by 1.5. So the proper way to write it would be the 1.5 in the front, but it's not wrong if you wrote an equals an minus 1 and then did like times 1.5. That would be fine as well. I'm guessing, oh, all right, we're going to evaluate a recursive sequence. So to evaluate a recursive sequence, I start with the term after the one they give me. So if they give me a1, I start with a2. And understand that an minus 1 means the previous term, the term before the one we're finding. So I'm going to sub into this. So it's 4 minus 3 times the previous term. If I'm finding the second term, the previous term is the first term, which is negative 3. This value is going into an minus 1. Use a calculator if you need to. I'm not going to do that right now. That's 13. Now that I have the second term, I can find the third term. Again, I'm subbing into this. So it's 4 minus 3 times the previous term, which is 13. Use a calculator if you need to. That's negative 65. And now that I have the third term, I can find the fourth term. It wants the fourth term. So a4 equals, I'm subbing into this, 4 minus 3 times the previous term, which is negative 65. I'm going to use a calculator for that one. 4 minus 3 times negative 65 is 199. I made a mistake. I was doing too much in my head. I believe that for A3, 4 minus 3 times 13 is negative 35. That'll do it. Which makes this 109, I believe. 4 minus 3 times negative 35 is 109. Oops, I'm glad I caught my mistake. We all make mistakes. You always want to double check your things, make sure it makes sense. And I just did that right there. A lot of words here. Key word is total. When you see total, if I look at my enhanced reference sheet, total is, oh, I shouldn't write this in here. That's a problem. I got to fix this. Total is SN. Total is SN, and specifically, I'm using my geometric explicit formula. So I'm going to write off of my reference sheet, SN equals A1, 1 minus R to the N over 1 minus R. I need A1, I need R, I need N. He runs 15 miles in the first week. A1 is 15. This is where students get messed up. 3% more. If you're increasing by a percent, it's 1 plus the decimal. So since 3% is 0.03, if I'm increasing by 3%, it's 1.03. If I was decreasing by 3%, well, I'm keeping 97%, R would be 0.97. 10 weeks, that's my N value. So I have S10 equals A1 is 15. 1 minus R is 1.03 to the power of 10 over 1 minus 1.03. I'm going to type that into the calculator. I've got 15, 1 minus 1.03 to the power of 10. Make sure the parentheses are in the appropriate spot. Over 1 minus 1.03. And I've got to the nearest thousandth. I've got 171.958. 171.958. Total is SN. You get that from your reference sheet, your geometric series, your explicit. We are going to end the first half here. We will pick up on the second half in a separate video. See you shortly.